If there is one thing that is becoming increasingly scarce in today's world, it is without any doubt energy. While there are many sources of energy, both renewable and non-renewable, solar energy is the most feasible and vital for both human usage and the sustainability of planet Earth. Unless you've been living under a rock, you've likely heard about solar energy. And most probably, when you hear the term solar energy, solar panel systems come to mind. But solar energy is far more than just solar panels. In today's video, we will talk about solar energy, what it is, how it can be used, and we'll discuss some of the latest solar energy technologies. So, make sure to watch the video till the end, and if you're new to the channel, make sure to subscribe to the channel and hit the bell icon, so you won't miss any future videos we upload. Getting back to the video, let's discuss the basics of solar energy. Well, in simple terms, solar energy is the energy we can get from the sun. The energy that originates from the sun is known as solar energy. A tremendous quantity of energy is emitted or radiated into space by the sun on a daily basis. In fact, the sun releases more energy into the atmosphere in one single second than all of humanity has consumed since the beginning of time. So, you must be thinking, where exactly does all of this energy come from? Well, it originates deep within the core of the sun itself. The sun, like all other stars, is a massive ball of gas that's mostly composed of hydrogen and helium. Nuclear fusion, which occurs in the center of the sun, is the mechanism through which solar energy is created. In the process of nuclear fusion, the extraordinarily high pressure and high temperature of the sun cause hydrogen atoms to split apart, which in turn causes the nuclei of the hydrogen atoms, which are the atomic cores, to fuse or merge. The formation of a single helium atom requires the fusion of 4 hydrogen nuclei. However, the weight of a helium atom is less than the sum of the weights of its 4 constituent nuclei. During the process of nuclear fusion, some matter is lost. The lost matter is discharged into space as solar energy. It takes the energy in the sun's core millions of years to make its way to the solar surface, and then it takes only a little bit more than 8 minutes to travel the 93 million miles to Earth. At the same rate that light travels, which is approximately 186,000 miles per second, solar energy makes its way to Earth. It's estimated that only 1 part in 2 billion of the energy that the sun emits into space makes its way down to Earth. However, this quantity of energy is quite enormous. You can think of it in this aspect. The daily energy sent to the United Kingdom is enough to meet the country's requirements for the next 15.5 months if all that energy was stored. However, the sun's energy that is directed towards the Earth is reflected back into space at a rate of around 15%. Another 30% is used up in the process of evaporating water, which is then carried into the sky and results in precipitation. Plants, the land, and the oceans all take in some of the energy that the sun provides. The remainder may be put to use in meeting our requirements for sources of energy. So, now to talk about how we can use that solar energy to meet our energy requirements. Since ancient times, humans have been able to take full advantage of solar energy. Simple magnifying glasses were used by people as early as the 7th century BC in order to focus the light of the sun into beams that were so intensely heated that they could set wood on fire. In France, over a century ago, a researcher used the heat from a solar collector to create steam, which was then used to power a steam engine. At the dawn of the 21st century, professionals in a variety of fields, including science and engineering, got serious about exploring new applications for solar energy. One significant step forward was taken when a solar cell was created in France in 1839. 4 decades later, in 1883, selenium wafers were used to make the first solar panel, which was then installed on a rooftop in New York City. However, the panel's energy conversion rate was just 1% at the time. After this, other applications for patents covering solar cells and solar panels were submitted in the United States. Nikola Tesla was awarded a patent for the solar panel. Albert Einstein's article detailing the theory underlying the photoelectric effect was published in 1905, and it was for this work that he was awarded the Nobel Prize in Physics in 1921. In 1954, Bell Labs was the first company to produce a silicon photovoltaic cell. Even though solar energy had been absorbed and transformed into useful energy through a variety of means in the past, it wasn't until after 1954 that solar power began to become a viable source of electricity that could power equipment for lengthy periods of time. The first solar cells were only able to convert solar radiation into electricity at a rate of 4% efficiency. As a point of comparison, many commercially available solar panels today can turn sunlight into solar power at a rate of more than 20%, and this number is always going up. You're probably already familiar with solar cells, but if not, watch the video to learn more about how they work. You've all seen solar cells used in solar-powered calculators, solar-powered toys, and many other things, including solar-powered banks. What solar cells do is turn light into energy. A solar cell is constructed by placing two very thin slices of silicon on top of each other and securing them with metal wires. The very top layer of silicon, known as the N layer, is extremely thin and contains a chemical that has been added to it specifically to give it an abundance of free electrons. The bottom slice, which is also called the P layer, is much thicker than the others, and a chemical has been added to make sure that it has few free electrons. An unusual phenomenon takes place when the two layers are brought into close proximity with one another. An electric field is generated, which serves to block the path of electrons as they attempt to go from the top layer to the bottom one. When a solar cell is placed in direct sunlight, bundles of light energy known as photons can enter the p-n junction and dislodge some of the electrons from the bottom P layer so that they fall into the N layer. This happens because the photons mess up the electric field that the junction makes. As a result of the N-rich layer's supply of electrons, an excess of electrons with a negative charge is generated. This surplus of electrons results in the production of an electric force, which then expels the extra electrons. Through the metal wire, these extra electrons are sent to the bottom P layer, which has lost some electrons as a result of the process. Thus, electrical current continues to flow as long as the cell continues to be exposed to the radiant energy in the form of light, and the channel, known as the circuit, continues to be closed. The PV cell technology that is available right now is not extremely good, as the PV cells of today are only capable of converting between 10 and 14% of the sun's radiant energy into usable electricity. On the other hand, fossil fuel plants are only able to convert between 30 and 40% of the chemical energy contained in their fuel into electrical energy. At the moment, the cost per kilowatt hour to generate power using PV cells is 3 to 4 times as expensive as the cost to generate electricity using traditional sources. The vast majority of solar power systems installed in homes are photovoltaic solar systems, which may be classified into grid-tied systems, solar plus storage systems or hybrid systems, and off-grid systems. The vast majority of solar panel systems installed in homes and businesses today are grid-tied, which means that they're connected to an existing electrical distribution network. Your solar panels will provide your home with the electricity that they generate. If your solar panels generate more power than your home requires, the excess will be fed back into the grid. When the electricity generated by your solar panels is not sufficient to meet your household's requirements, you can make use of the power provided by your utility company, because your home is still linked to the grid. Not only are grid-tied systems the most common sort of home solar power system, but they're also the most cost-effective type, given that they don't require any additional equipment for energy storage. Therefore, a grid-tied solar system is probably the best option for you if you're on a budget. Solar plus storage systems, also known as hybrid systems, are solar panel arrays that are connected not only to the electrical grid, but also to an on-site solar storage device, which is often a solar battery. Your solar panels will continue to provide power to your home throughout the day, just like they would with a system that's connected to the grid. When you create more solar electricity than is required by your home, the excess power is stored in your battery rather than being routed back to the grid. When your solar panels aren't producing enough electricity to satisfy your requirements, you can use the stored energy, which will result in a redirection in the quantity of power that you purchase from your power company. Off-grid solar power systems are not connected in any way to the conventional electrical grid. Going off the grid isn't a very good idea if you live in a region where you can easily connect to the power grid. It's just not practical. Off-grid solar power systems, for one, tend to have higher initial investment costs. To be able to cover all of your energy usage with solar power, you need a huge number of solar panels and a significant amount of battery storage, both of which are expensive investments. In addition, you might need to make some significant adjustments to your lifestyle if you want to reduce the amount of power that you use. Oil shortages and price hikes in the 1970s were a driving force behind the movement towards alternative and renewable forms of energy. Today, there is a resurgent concern for the environment, which is driving the movement towards the use of renewable energy sources, most significantly solar energy. Solar power is the gold standard when it comes to ecologically responsible forms of energy production. It doesn't pose a threat to human health, doesn't contribute to pollution of the air, water, or noise. It doesn't constitute a threat to the environment in the form of waste products that are hazardous to the environment, and uses none of our valuable energy resources. There are further benefits to this as well. There's no way for a single nation to monopolize or restrict access to solar energy, and there's no danger of running out until after the sun goes down. That's all for today's video, guys. What do you think of today's video? Tell us your views in the comments section. Thank you very much for taking the time to watch this video. See you in the next one. Until then, best wishes.